Welcome back to Math with Rhyme or Reason. On this final video as far as multiplying and dividing radicals, I just want to do a bunch of examples. So if you're comfortable with everything, then you don't need to watch this. But I just wanted to do a few more. Some of these are more complicated and some of them are just another way to look at things. So let's start with root x plus 5 and 2 root x minus 3. All right, this is straightforward. All the jails are the same, so we can just FOIL things out. So when I multiply that one times that one, I'm just going to get 2x. The outside is minus 3 root x. Inside is plus 10 root x. And then the last two is minus 15. These two simplify, so you get negative 3x plus 10 root x is 7 root x and minus 15. Okay? And everything is as simplified as it can be. There's nothing more complicated that we can do. On the next example, what I wanted to remind you about was squares. So if I take this and square it, the temptation is to just square this and square that, and so you would end up with x plus 25. That's not correct. So if you do that extra step that I reminded you about in the other video, rewrite what squareds mean. That is, a squared means take the number times itself, or in this case, the binomial times itself. Now you have to FOIL it out. So first one times first one is x. Outside is 5 root x. Inside is 5 root x. And the last two is 25. So when you combine the like terms, you get x. 5 root x plus 5 root x is 10 root x plus 25. Okay? Not the same thing as just multiplying out the first one and multiplying out the second one. Sorry, squaring the first and squaring the last. There's that middle term there that you don't want to forget about. And so the easiest way to remind yourself of that is to multiply them out. Okay. I wanted to show you one that I thought was a fun example. And I also wanted to do one that has fractions involved. So I'll do that one first. Let's do something like 28. Oops, it's 28 x squared. Oh, x cubed. Changed my mind. And I'm going to put it over x, and I'm going to add 63 x over 4. Okay. So, first thing I'm going to do is jailbreak both of these guys. So, that will give me prime factor. I'll prime factorize first so you can see what I'm doing. So that will be 2 times 2 times 7 times x times x times x. And that's all over x. Okay. And this one, I'm going to prime factorize. I get 3 times 3 times 7 times x. And it's over 4. Okay. So out of this guy, one of the 2's breaks out, one of the x's breaks out. Oops. That 2 doesn't make it, that 2 doesn't make it. So we have a 2x out front, a root 7x in jail. Oops, that's a 7x. And that's over x. This one, 3 breaks out. That's it. This one dies. And we have root 7x over 4. Okay. On this one, we can simplify the x's. So we have 2 root 7x plus 3 root 7x over 4. So now you have to make sure you know how to do fractions. So 2 plus 3/4, you can do it that way, right? You can do 2 root 7x's plus 3/4 root 7x's. Okay, and that's 11/4 root 7x. Now some of you like to keep that in mixed numbers, which of course is 2 3/4. I prefer improper fractions because when you're working with mixed numbers, the very first thing you have to do is switch it to improper fractions. Let's pretend though that this x didn't simplify. So if we make this slightly more complicated, I want to make sure I don't mess up anything. I'm going to change this to an x and this to an x squared. I think that's what I want to do. We'll see what happens. Okay, most of it is the same, obviously, but there's going to be one other glitch. So I'm still going to prime factorize, and I'm still going to simplify. I'm going to do everything that I did on the first one. So that will end up giving me 2x root 7x over x squared this time. And in this case, out comes this 3 still, so I'll have 3x root 7x over 4. Okay, so almost the same as last time, except my denominator here still exists. So, what did I do? I didn't want to do, yeah, that's okay. So in this case, I need to get a common denominator because I still need to add my fractions. So I'm going to change this guy to, well, my common denominator will be 4x. Let's start there. Okay. So I'm going to have to multiply this one by 4 over 4, which is 1. And I'm going to multiply this one, just move it over a bit, by x over x. Again, I'm assuming x is not 0. All right, what does that do? Over here, I end up with 8 root 7x over 4x. And here I have 3x squared root 7x over 4x. Okay? If I'm trying to keep a common denominator, that's as simple as I can get. So I would have 8 root 7x plus 3x squared root 7x. Okay, you could split them up like I did and simplify them, and then you get back where you started. It depends how you want your answer to look. All right. If these had been like terms, then I could have also combined them. All right. And the last example I want to do is kind of cool because there's a bunch of ways you can solve it. Sorry, simplify. It's not an equation. Okay, so there's the example. And like I said, there's a bunch of ways you can tackle this one. So one of the ways you could do it is you could simplify your radicals first. So that would give you 5 plus 5 root 2 over 5. I'm jailbreaking. This is 5 times 5 times 2. Same thing here. 5 minus 5 root 2 over 5. Okay. Carefully, I can simplify the fraction. So what I'm going to do is pull a common factor out of my numerator. And I wanted to do this example partly for this reason. The 5 over 5 can simplify because this is now multiplied. All right? Don't lose your 1 when you're pulling out the GCF of 5. So I'm going to do it again on this one. If I pull out a 5, I get 1 minus root 2 over 5. And again, the 5's simplify. So I end up with 1 plus root 2 times 1 minus root 2. Whoops, it's a bit squishy there. All right. If I FOIL that out, I get 1 times 1 is 1. Minus root 2 plus root 2 is 0. I can actually write that in here. We'll move that over then. Okay, so I get 1 minus root 2 plus root 2 is 0. And then minus 2. So I end up with negative 1. That's kind of cool. All right, a second way that you can do this one, and hopefully we end up with the same answer no matter which way we do it. Is almost the same, except you can take out, you can split up your fraction. So you could do 1 plus, and I'm going to jailbreak this at the same time. So I would get 5 root 2 over 5. Actually, I'll do one step in between. This is 5 over 5. Because they have the same denominator, I can also split it up into 2 fractions. So then I would have 5 over 5 minus 5 root 2 over 5. Okay, that simplifies to 1 plus, those also simplify, root 2. 1 minus root 2. And then, similar to the last one, once I FOIL that out, I get 1 minus 2, which is negative 1. So that's another way you can do that question. The other way that you can do this question is to recognize that you have difference of squares, and so what would happen if we just FOILed it out right away? So what I'm going to do is multiply my numerator. I'm going to FOIL out my numerator, multiply my denominators, and simplify. So 5 times 5 is 25. Minus 5 root 50. Plus 5 root 50. So those will add to 0. And minus 50. My denominator is just 5 times 5, which is 25. So these add to 0, and 25 minus 50 is negative 25 over 25, which is negative 1. So one of the things as I'm teaching in my classroom is that I realize that everybody has different brains. And so how you see a question helps determine how you answer it. All of these ways get you the same answer, but I wanted you to see that you could do it in a whole bunch of ways and think about things differently. In the next video, we'll be talking about how to solve rational equations. That'll be the last series. We'll see you soon.